Hey guys, so here is the start of the videos going over our questions for our fourth and final exam besides the final that we are going to take in Math 121. I have somebody else here with me working through these things. So first one, and I'm going to go through these questions where I deleted all of the numbers and we are just going to practice doing one for each one. So for the function, I'm looking at the test right now. I'm going to put something very similar to what's on the test. For the function 4 to the power of 5 minus 2x, it wants us to find f of, let's try negative 4. Okay, so technically you could just put this into your calculator just like this if you wanted to. Except everywhere we see an x, of course, you're just going to put in the calculator. And my friend here doing it is going to do it for us. So we're going to do 4 to the power of 5 minus, oh look, it's going to be actually plus 2 times 4 is 8. Because a negative 2 times a negative 4 is going to be a positive 8. So 4 to the power of 5 plus 8 is going to give us a very large number. It might not be this large when we do it on the test. 6, 7, 1, 0, 8, 8, 6, 4. So if I go back in and put in my commas, I can see that I have what? 67,108,864 is the answer here. On the test, I'm not sure it will be, well, it'll be a pretty big number on the test too, actually. But just one, easy enough to put into your calculator. Now, sorry, you guys. Hold on. Oh, no. How do I get it back? Print, layout. All right, sorry you guys, we're just gonna roll with this. The second one is the bear population, and I guess this was a hot debate at the CCD math department, where some people wanted to use a continuous growth function and some people wanted to use just the regular exponential function. I am okay with either one that you do, but we can do it both ways here. So let's make up a rate of 8%. Okay, so our bears are growing at an annual rate of 8%, and in 2010 there were 300 bears. Okay, write a function f of t that models the number of bears t years after 2010. So don't forget also, guys, 2010 is going to be our x equals 0. That's going to be our starting year. So if you were going to do it the way we do a normal, like, exponential function, you would have f of t is equal to your initial value of bears, which is 300, times 1 plus our rate, which is 8%. Do not make the mistake of putting in 8% as just 8. Needs to be as a decimal, which is 0.08. And then to the power of t years. If you wanted to use the continuously compounded method, if I want to use the continuously compounding method, we are going to use the a equals PE to the RT, and that would be a of t equals our initial value of 300 again. This time, e to the power of our rate, which is 0.08, times t. Okay, and then we'll use both of these functions, and the answers shouldn't be that far off from one another. So what is the population of bears predicted to be in 2025? Well, if 2010 was year 0, 2025 will be how many years later? 15 years later. So we want to know where t is equal to 15. So on this side, we are just going to put into our calculator 300 times 1.08 to the power of 15. And my friend's going to do that, and I am going to put into the calculator a of t equals 300e to the power of 0.08 times 15, and we should get very similar answers. You can be putting these into the calculator as well. E to the power of 0.08 times 15. What'd you get? Nice. Okay, so if you used the f of t function, you would get approximately 995 bears. If you use the a of t function, you would get approximately I can make those approximate signs. Approximately.
This one is 950.
Oh, 951. Sorry. 951. And this one would be approximately 996. So not too far off, but you can tell if something is being continuously compounded, you're going to get an answer that's always going to be higher than if it is not. Now, the big debate in the math department was that if bears are hibernating for half of the year, can they be continuously making babies, right? So that's why we're okay really with either way that you would like to do this. All right, question number 3. Suppose an investment account is opened with an initial deposit of $500. And we are earning 6.2% interest compounded monthly. How much will the account be worth after 25 years? Okay, so 500 isn't much to be putting in, but let's see, which equation are we going to be using? It's going to be, this one at the top. And since this is exactly the test, know that this will be the one that you should be using on the test. All right, so A is equal to, P is our original value. Oh, we have 82% left, you guys. So we have 300. Why does it do that? 300 times 1 plus. Do not forget to turn your percent into the correct decimal. Do not put 0.62. It is 0.062 divided by, that's my rate, divided by n. N is how many times it is compounded per year. So since this is compounded monthly, our n is going to be 12. Parenthesis to the power of n, 12 times t, which is 25 years. Okay, so you should be able to put that directly into a calculator. I'm going to do that. I'm going to pause. Why don't you do that too? Make sure you get the same answer as me. You guys, so I put them into the calculator, and we got that after 25 years, our account is going to have approximately 1407. Can you give me to the hundredths, please?
0.81.
0.81. Okay. So, deposit more than $500. That's why for like retirement accounts, we need to be adding to it monthly to make that number be growing more. So question 4, show that this equation is equal to a different equation. All right, you guys, actually going to stop this video and start that one with another one, because that's going to be a little proof and it'll be a little bit longer than we have left.